So there's just a couple more things to talk about with this unit. These are pretty straightforward. I hope this doesn't throw you for a loop. This is one place I'd rather have been there than at home doing this. But when we did this, in fact, I can just do this. Let's just do this, shall we? When we did this thing, um, if we add more particles in there, what happens to the pressure? So let's lock the volume. If I add more particles in there, look at the pressure going up. So the pressure goes up based on how many particles you have in there. And basically, the sum of the pressure is the pressure being caused by the red plus the pressure being caused by the yellow. That should make sense, right? The red is doing some partial pressure of that 5, and the yellow is doing the rest. And combined, they equal 5. So that's called Dalton's law of partial pressure. So if you have a mixture of gases, each individual gas contributes to the total pressure, and the pressure is additive. Basically, the total pressure is equal to the pressure of whatever gas 1 you have, gas 2, however many gases you have in there. The key here is that you have to make sure all the pressure units match. You can't add atmospheres and kPa and millimeters mercury. They all have to be in the same unit. So there's 3 gases in a container, has a total of 2 atmospheric pressures. So the total is 2. And it's in atmospheres. So we have to make sure everything else we're going to add here is in atmospheres. There's hydrogen in there, and that's 0.23. Okay. And there's chlorine in there, and that's 0.939. And the question is, well, what about the rest? What about the oxygen? What about the oxygen? So you just have to add everything. So 0.23 plus 0.29, 0.23 plus 0.939 is 1.169. So 2 is equal to 1.169 plus whatever oxygen was, right? 1.169. So therefore, whatever oxygen is has to equal, since we're adding, we need to subtract, and you get 2 minus 1.169, 0.831. So that must be what the pressure of oxygen is if all 3 of these things equal 2. So it's not that difficult. The reason we teach you this is because of this kind of a question. Often, and as we did in the little mini demonstration I did with carbon dioxide, you'll collect a gas over water. And because of that, water has some vapor pressure and it's additive to what's in there. So in this case, you're collecting neon. So let's say you do something and you collect neon up here. This is neon. And because there's water here, there's a little bit of water pressure. So a little bit of water in here with all the neon. Pardon me. All right. So we want to subtract out the water. So the total pressure is 799.5 millimeters of mercury. And we know that water is contributing 23.7. And then the rest will be the neon, partial pressure neon. So if you want to figure out what the neon was, you just subtract 23.7 from the big number. So 799.5 minus 23.7. So neon had to be contributing 775. 775.8 millimeters of mercury is what the pressure in neon was. Okay, so that's fun, right?